The beneficent, the merciful, the creator and sustainer of the universe. Peace and blessings upon his servant and messenger Muhammad forever. Ameen. I greet you with greeting as common in Islam, greeting of peace. Assalamu alaikum. I'm your host, Hamid Rashid. Today we have our 8th program in our series dealing with the economic system of Islam, and we'll be continuing with our discussion of the topic of production and productivity. Actually, this will be our 4th program on this particular topic. I have joining me on the program as usual Dr. Jamal Badri of St. Mary's University. Brother Jamal, assalamu alaikum.
Alaikum assalam wa rahmatullah.
I found last week's program very interesting. I wonder if perhaps I could have you very quickly summarize and highlight the main points that we touched on. We were discussing some of the contributions of Islam to the various sciences.
Sure. Last week's program was a continuation of the tracing of the effect of progress in Islamic sciences or Muslim sciences in the so-called Middle Ages and its effect on the Renaissance in Europe. We tried to look into some of the basic routes through which Muslim learning and Muslim sciences penetrated into Europe, including Europeans learning in Muslim universities as well as the Crusades to some extent. We started to give specific examples of historical manifestation of this attitude that the Quran teaches about science and learning, and we discussed more particularly the issue or the area of astronomy and chemistry, and gave various examples of chemical material that is still holding the name or named after the Arabic original Islamic names, like the invention or the discovery, I should say, of alcohol. So this was basically where we at in the present time.
Mm-hmm. Well, now today we'd like to address another important discipline, and that is in the area of mathematics, certainly an area that's very important whenever we talk about scientific progress.
Mm-hmm.
I understand that the numerals that we use are called Arabic numerals. Could you explain how that came to be?
Well, these numerals that we're using at the present time originally were practiced or used in India. However, to Muslims goes the credit of popularizing the use of these numerals and bringing it to Europe and introduction to the world at large, in fact. For that reason, it came to be so much identified with them because of the development that they made also in arithmetics, that they came to be known as Arabic numerals. In addition to the numerals, we find that one of the great Muslim mathematicians by the name of Muhammad bin Ahmad, and we're talking here about the 10th century, he actually invented, if you will, the concept of the zero. You see, zero in Arabic means sifr, the Arabic word for it, which means void. And that is related, in the opinion of some scholars, to the term that came to be known later on, cipher and decipher.
Oh, yes.
See? The discovery of the zero was not really a simple thing, but according to many science historians, it revolutionized the discipline of mathematics. It made it possible to express all numbers in 10 characters, giving them absolute value and a value by position. And in fact, without this, the whole later development of mathematics would have been stifled. It is interesting to note that the zero as a concept came to be known in Europe only about 300 years after Muslims have already used it in the 13th century. So it took 300 years before it became common in usage in Europe, and still ever since.
Now, it's also claimed that the term algebra comes from Arabic, and that it's connected with Islamic civilization. Would you perhaps clarify that for us?
Yeah, that's also true. In fact, when you talk about algebra, basically we're talking about what? A sort of means of universal arithmetics, a sort of arithmetics. As the mathematicians define it, it's the use of numbers, letters, and symbols in order to analyze and express relationship between concepts of quantity in terms of formulas, equations, or to put it in a simpler way, calculation by symbols. The term, as you indicated, actually has an Arabic origin, al-jabr in Arabic. And al-jabr in Arabic means literally to unite or to put pieces together. Mm-hmm. This was initiated, in fact, by the Muslim mathematician Muhammad bin Musa al-Khwarizmi, who lived in the 9th century and was connected with the Bayt al-Hikmah, or House of Wisdom, that we mentioned before, in the 9th century, which was established in Baghdad. His book on the subject, called Hisab al-Jabr wal-Muqabala, which means in English calculation by symbols, more or less, became actually a classic that for hundreds of years provided the basis for further studies in mathematics. The other interesting thing about it is that you notice the name Al-Khwarizmi.
Yes.
Algorithm.
Oh, yes.
Actually, the word
quite close, yeah.
Actually, the word algorithm comes after the name of Al-Khwarizmi, or the science of decimal system of counting. That was also introduced by him. In fact, one of the historians, major historians on the history and development of science, George Sarton, that we quoted before, says about Al-Khwarizmi that he is, quote, one of the founders of analysis or algebra as distinct from geometry. Make algebra a distinct type of discipline. In addition to this, we find there are so many other mathematicians who contributed to the field of algebra, like Abu al-Watha, who lived in the first part of the 10th century. He did a great deal of study to perfect the work of Al-Khwarizmi, and he did some work also on quadratic equations. In fact, according to Sarton also, many of the works of the Muslim mathematicians passed on to Europe through translation from Arabic to Latin by such people as Robert of Chester, Abelard of Bath, and John of Seville.
Well, now you mentioned that Muslim mathematicians have contributed to making algebra a distinct field from geometry. Did they also contribute to geometry as well?
Yes, a great deal. In fact, without the contribution of Muslim mathematicians in this area of geometry, many of the golden treasures of the past, work that was done on the subject, would have been totally lost. Take, for example, the work of the famous Euclid.
Yes.
Well, without Muslims being keen about learning and preserving that heritage, it would have been totally lost to history. In fact, the first translation in Arabic of Euclid's work was done in the first half of the 9th century. And from that Arabic translation, that heritage was passed on again to Europe later on by being translated again from Arabic, not from original, because the original was already gone, It was translated from Arabic again to Latin. But it was not simply a matter of really preserving learning of the past, but there were also lots of additions and commentary made on it as early as the 9th century. One of the most important commentaries on Euclid's work in later times came in the 13th century by Nasr al-Din al-Tusi. In fact, his commentary and critique of Euclid provided the impetus for the study of non-Euclidean geometry. It influenced tremendously people in the 18th century who were the forerunners of the so-called non-Euclidean geometry, which emerged mainly in the 19th century. But in addition to this, we find that, according to, again, George Sartre, I make frequent reference to that, it's one of the most tremendous works done on history of science. He indicates that in the 13th centuries, the leading books in geometry were basically in Arabic and Latin, and one would expect that many of the Latin works also with translation from the original Arabic works. In fact, it was not simply the attention that is given to the theory itself part, but the Muslims were also quite practically oriented, and that led to the development of a sub-area also, the science of trigonometry.
Mm-hmm. Well, could you perhaps shed some light on the developments in the field of this latter field of trigonometry?
Well, trigonometry is a very important field in mathematics. As you know, it has a variety of applications, particularly in the area of surveying, navigation, and also in engineering. Mm-hmm. According to John Draper, we quoted him before also in the history of, or intellectual history of Europe, he indicates that Muslims were the first actually to develop trigonometry in its modern form. Of course, the Greeks also had some knowledge of trigonometry, but Muslims developed it in its modern form. In fact, they were the first to use the sine and cosine. Al-Batani, for example, is credited by that. But this probably would be related to their interest, their deep interest in astronomy, because you see trigonometry is connected also, had lots of application in astronomy. It is interesting to notice that some of the works done by Muslim trigonometrists, if you will, in that field, on the trigonometry of tangents, was not known in Europe until 500 years later. It took 500 years actually for that work to pass on to Europe. Some works passed faster than others, but this was one of the areas where it's very strange how much time it took before it was used in Europe. They also wrote on spheric trigonometry, which again might be related to astronomy, and that led George Sarton in his Introduction to History of Science to say, and I'm quoting him, that's in volume 2, part 1, page 12, he says that the development of trigonometry was entirely due to Muslim efforts for a certain period of time during the so-called Middle Ages. Let me also refer to a quotation directly from George Sarton, which appear also on the same page. He says, "This outline of trigonometry in the 12th and 13th century cannot but give the reader a very high idea of Muslim science. Indeed, all the progressive work to the very end of this period was published in Arabic. Latin trigonometry was but a pale reflection of the Arabic, and it was already a little behind the times. It was little behind the times when it was new, for the Arabic efforts did not stop, but continued with increased efficiency." So this is really a fascinating area also, where a great deal of contributions was offered by Muslim mathematicians and really provided the impetus and inspiration for later mathematicians to continue on that work.
Well, I'm sure that many of our viewers would find this very interesting information. Are there other examples or additional illustrations of contributions to the field of mathematics that you might be able to share with us?
Sure. For example, if you go back to the, let's say, the 10th century, particularly the second half of the 10th century, we find a Muslim mathematician by the name of Abu al-Wafa, regarded by historians as the first one to show the generality of the sine theorem relative to the spherical triangles. He also gave a new method in constructing the sine tables. In the 11th century, the second part of the 11th century, almost a century later than Abu al-Wafa, very famous mathematicians like Al-Bayruni and Ibn Sina, known in the West as Avicenna, the last one, gave, according to Sarton, lots of work, or produced work which was generally of a high level and very high level, he used the term, and full of originality. In Egypt also a great astronomer and mathematician in the 11th century by the name of Ibn Yunus contributed a great deal also. But one of the fascinating contributions also came in the second part of the 11th century by a man who was known and still known in the West more as a poet than a scientist. That's Omar al-Khayyam, or Omar Khayyam as known in English. This fellow was so bright in mathematics that he, according to Sarton, conceived a very remarkable classification of equations. For example, it is said that he recognized 13 different forms of cubic equations. That's rather complex, at least for the time. He tried to solve all of them, and he even gave partial geometric solutions to some of those equations. In addition to this, we find other people contributing to other branches of mathematics. For example, and you'd be surprised at the time, in the first half of the 11th century, we find a Muslim mathematician like Ibn Samh contribute to the field of calculus. Others also contributed in a field that might sound relatively new to many. That is the so-called commercial arithmetics. He called it al-mu'amalat, the Arabic equivalent. Mu'amalat, that's dealings, or commercial arithmetics.
Well, now, perhaps we could move at this point to another discipline which is closely related to the field of math, and that's the field of physics. What would you consider, in your opinion, to be the single most important contribution to this field?
Well, it would appear, and that's not only, my opinion. I think historians of science, people who have studied this more than I did, of course, agree that perhaps the most important single contribution of Muslim physicists was the science of optics. In fact, you cannot really speak of optics if you try to trace it historically without mentioning the name of Al-Hasan ibn al-Haytham. Again, the adulterated Latinized name, which make it difficult sometimes to read, is Al-Hizn. You write it A-L-H-A-Z-E-N, but actually his actual name is Abu al-Hasan ibn al-Haytham. He lived in the first half of the 11th century, and he was described by George Sarton as, quote, the greatest Muslim physicist and one of the greatest students of optics of all times. Al-Hizn, or Ibn al-Haytham, according to Sarton, exerted a great deal of influence upon Western science, and he further showed a great progress in the experimental method, and that was like the forerunner of Bacon and Kepler. And as a result of his works, we find that the development and the use of the microscopes and telescopes came at a later time. One of the main reasons for this contribution is basically one classic that he wrote called Kitab al-Manadhar, or Optics, for brevity. Indeed, this work is regarded by historians as the beginning of what you might call the modern science of optics. Let me give you a few examples, if I may, on some of his bright discoveries. And again, we're talking here about the first part of the 11th century.
Yes.
First of all, up to his time, there was a common misconception, particularly in Greek science, about how the person sees, or what is the source of sight. And in Greek science, they used to believe that a ray of light,
yes,
proceeds from the eye. So when you look at something, the ray of light comes from the eye to the object. He corrected that, and he indicated that the ray of light actually emanates from the object to the eye, and not the reverse. That, for that time, was really a major shift in the science of optics. In addition to this, he showed a great deal of understanding of light refraction and light deflection. Both are very important phenomena in physics. And in fact, he arrived at a very important discovery for his time, and that is the curvilinear path of the ray of light through the atmosphere. And this led him to explain the concept of twilight. That is why we are able to see the sun and the moon before they rise and after they set. That was basically based on this concept of curvilinearity of the path of the ray of light. Another interesting thing is that in a very early age of scientific development, like the 11th century, he was able to determine that the retina in the eye is actually the seat of vision, and that the impressions which are made by light upon the retina is conveyed along the optic nerve to the brain. That sounds quite advanced even when you look at it in time perspective. He was able also to explain why is it that we see with a single vision even though we use two eyes. In other words, you still have to explain the phenomena of a single vision using both eyes. And he had a very nice explanation. He said that it is due to the formation of the visual images on the symmetrical portions of both retinas, of both eyes. No wonder then that we find that many of his works, particularly this particular treatise on optics, were translated and used over and over again for several hundreds of years, that's for several centuries, in Europe after him. Definitely Al-Hazim or Ibn al-Haytham is perhaps the most outstanding physicist, at least in the area of optics. But in fact he was not the only one. There are some other Muslim physicists who introduced additional improvements, such as Nasir-ud-Din al-Tusi, Qutb-ud-Din al-Shirazi, and Kamal-ud-Din al-Farisi. These were also notable contributors to optics.
Well, I wonder if I could ask you in the time that we have remaining on today's program to perhaps touch on some of the other contributions to physics other than to the field of optics that we've just been discussing.
Well, for example, one of the most important things that revolutionized trade and really resulted in the improvement of navigation is basically the compass.
Yes.
See? Now, it is true that the Greek knew something about the properties of the magnet. All right? It is also true that the Chinese understood some of the basic directive properties of the magnet. There is no denial of that. But in fact, according to historians of science like George Sarton, these people or these nations were not able to put this knowledge and information into practical application. And it is believed that it was the Muslims actually who adopted these ideas and put it into use, and were the first actually to use the magnetic needle for the purpose of navigation. This is one. Another interesting aspect was the investigation in the field of hydrostatics, which started as early as the 9th century even. One of the interesting books written on the subject was written by a person whose name is Abdul Rahman al-Khazini. The book title was Mizan al-Hikmah, which if you translate it literally to English means like the balance of wisdom. But actually he was really talking about hydrostatics. George Sarton describes the work of al-Khazini in the following terms. He said that standard work on this subject was written by al-Khazini, and it is one of the main physical treatises of the Middle Ages. It was a principal source of knowledge on this particular area. And then he gives some of the basic contents of this book. He says he worked on tables of specific gravities. Okay? So not just knowledge of gravities, but he really specified certain gravities of certain liquids and solids. And he talked also about a variety of physical facts and theories. That's also found in the second volume of Sarton in the first part. Another aspect that might also be of interest both to physicists and engineers also
Yes.
is the area of hydraulics, not just hydrostatics, hydraulics. Now, it is true that the idea of water wheel was known in past history. I mean, there are some records or archaeological evidence that it seemed to have been known. However, according to certain also, the Muslim physicists and engineers introduced a great deal of improvement on the use of these water wheels. And he actually, to use his term, he said they made very remarkable use of them. That, in fact, might explain the great deal of prosperity in agriculture, another issue that we might later touch on, but it contributes a great deal to various methods of agriculture and improvement in the production in this particular area. In fact, historians narrate that evidence shows that, particularly in Syria, in the 13th century, this water wheels have been used quite frequently and efficiently. He gave particularly the name of the city of Hama in the 13th century, and he said that there were as many as 32 efficient water wheels that has been in use. And by the way, this is the same city which was attacked by the unbelieving oppressive army of Hafiz al-Assad in Syria, in which nearly 20 to 30,000 people were slaughtered. It's the same city that the reference was made to the water wheels. So if you really look at it, it's so overwhelming to see the strides that were made in this particular field and all others, as the science we discussed before, astronomy, mathematics, and I hope also we'll be able to have a look on some of the additional and very important contribution made in other sciences. By the way, we're not simply saying that all the contribution were just in science.
Yes.
We'll be able to see later also that contributions to fields like geography, history, and other fields, law, has been just as remarkable. We simply started by investigating contribution to science because that stands clearly in the face of some of the erroneous arguments and impressions that might be predominant in the West, as we indicated in the beginning of dealing with these particular topics. That Islam stands against progress, that it's only befitting, as you might get from movies and all writings, it's only befitting for nomadic people riding camels and living in the desert, a simple life, because that's what Islam is. And what is really forgotten is these great contributions to the development of sciences, which continued over several hundreds of years, paving the way for what we know today as the modern scientific progress.
Mm-hmm. Well, I think we will stop at that for today. I think we've hopefully been successful in dispelling some of those stereotypes that you've just been talking about. We want to thank you for watching and invite you back next week when we'll continue with a contribution to the field of medicine. Thank you for watching. Assalamu alaikum. Peace be unto you.
الله أكبر الله